everybody. Welcome to Peak Work STEM. And today I'm going to talk about a key part of Unit 4 and AP Statistics, which is for binomial and geometric distributions. So, there's a lot of explanations on binomial and geometric distributions, but I'm hoping that you could leave here today with a better understanding on how to differentiate between the two and how you can understand if it's a binomial or if it's geometric distribution and when to even use them. So first, let's start off with a binomial distribution. So to begin with a binomial distribution, you have four conditions that need to be met. And a nice way I like to remember them is using bins, which is if it's binary, that means there could only be a success or a failure. Where there's independence, that means that every outcome is independent of each other, that it doesn't affect each other. There's a set number of trials. So this is the main thing that's like really differentiates between the binomial and geometric, but I'll get to that later. And also a set probability. So that means you always need to have a constant probability. You can't just keep changing probabilities. When you have a set probability, that's when you know you should probably use a binomial or geometric distribution, but I'll get more into that later. So let's shift our focus to geometric here. And similar to binomial, there also needs to be two conditions is binary and independent, meaning that once again there has to be either a success or a failure for both the binomial and geometric distributions. Also, independence needs to be met where every outcome is independent of the next. Let's say you're rolling a die. So if without replacement that would be independent, but if there is if there isn't replacement, oh sorry, if there yeah, yeah, if there isn't replacement, then like if the die just doesn't get replaced and that you keep taking um or you no die isn't a great example, sorry. Let's say you're taking marbles out of a jar, right? And then you have like red marbles, blue marbles, green marbles. You'd want to see if that's independent of each other. um you would really see if, let's say you didn't replace it, you take one out, you put it to the side, that would impact the probability of an upcoming marble being chosen. But I'll get more to that in another video about independence. So what I really wanted to differentiate between the binomial and geometric distributions here is that a geometric distribution is trying to see like the probability that you get your first success at a trial. So I'll give an example of that later, but the key thing that the College Board wants you to like differentiate between them is that a binomial distribution has a set number of trials, but a geometric distribution has the you're trying to find the amount you're trying to see the probability that something happens in a first success at a specific trial. And similarly, they both have a set probability. Okay, so let's go down to a binomial distribution here real quick. So first, for a binomial distribution, you would calculate the mean by doing the sample size n multiplied by the probability. That's what's going to give you the expected mean value. So let's say you have a n value of 50. Your sample size is 50, okay? And then you have a probability of 0.2, let's say. And then a question asks you, what is the expected mean of a what's the probability? No, not probability. Like what would be expected mean value? And you would have to see, is there a set number of trials? Are those bins or bit conditions met? So in this case, that would be, you would just multiply 50 times 0.2 and you would get a value equal to 10. Okay? By the way, these formulas that I'm going to talk to you about today, the binomial mean and standard deviation, as well as the geometric mean and standard deviation, are both on your reference sheet that you're given during the AP Stats exam. So let's talk about the standard deviation. So let's say in a binomial distribution you get this is your mean, but you're also going to have to calculate your standard deviation. And how do you do this? So very similar, but you're multiplying your sample size that we had, our probability, and 1 minus our probability. So, and then what you're going to do is you're going to square root all of that. So that's pretty much all you need to know really to calculate the standard deviation of a binomial distribution. Oops. Okay. So let's use this example before where we had a sample size of 50, probability of 0.2. So this would equal the square root of 50 times 0.2, and 1 minus 0.2 would just be 0.8. Okay. And then once you do that, you have to square root everything. So calculating that value, you would get in this case a standard deviation of approximately 2.83. 2.83. So really that's what you mainly have to know for calculating the mean and standard deviation, but I will give an example of how we would really see it in a problem, even though there might not be the best handwriting. Um, I hope you would still be able to understand. Okay, let's go to the example. Okay, so let's say a person kicks a soccer ball 50 times. So what is that? That's our n value. 50 times. So that's our value of n. And there is a 0.8 probability that she scores it. So that's the probability of success, right? The probability she scores it. That's success. That's what you want to see. What's the probability that they score it? This. That's just your probability. So here I showed it straightforward as it's just an introduction to binomial geometric distributions. But what is the expected mean and standard deviation? Well, that's so simple. We go back to our reference sheet and we use these formulas that are given to us here, right? We use these formulas. So that's simple, sorry. That's simple. We just use those formulas given to us. So first let's look at the mean. So what was our formula for the mean? If we're going to calculate the mean, we have the formula of um, blanking, sample size times the probability. So pretty similar to what I did there. Um, so here the sample size is, once again, like in our example, 50. That doesn't mean it's always going to be 50, but just as an example here. The probability of success, what we're really looking for, is 0.8. And so this would equal to 40, right? So if they ask you what's the expected mean, or what's the mean of this distribution, as long as you have those conditions met from all the way over here, if it's binary independence, I strongly suggest that you check all of these, because on an AP Stats FRQ, you don't need to on a actually you would need to on a multiple choice as well, um, unless they say assume all conditions met. But make sure these conditions are met, because that's what's going to give you the basis to be able to even conduct this. Okay, let's go back. Sorry. And then let's go to our standard deviation. So what could we do for our standard deviation here? So it's our sample size of n times probability times 1 minus probability. And I know there's some people who write this 1 minus probability as q. It's the same thing. So what would that be? That'd be the square root of 50 times 0.8. 1 minus 0.8 is 0.2. This was just a pure coincidence of matching like the example, but that doesn't always mean that that's going to be the case, right? So 8, 3. Okay, so this is for the mean and standard deviation of binomial. Now imagine, let's just imagine, okay, that they're asking us for probability now. I know it may be surprising, but let's say that they do ask us for this probability. Even though you may be overwhelmed, you still should check these conditions. And so basically, there's two things you could do in your calculator. There's a formula for the binomial distribution, which I will demonstrate, and there's also the how you could an easier way to do it in your calculator. You'll still get credit for it. You just gotta still write out your calculator work on your AP exam. Alright, so here we have a here we have what you would do to calculate probability that is very, very common in AP Stats, multiple choice, and FRQs. Matter of fact, on my own AP exam, it showed up multiple times. So the formula that the College Board gives you is this. This entire thing is the formula the College Board gives you. And it may seem overwhelming at first, but there's a simpler way to do this in your calculator. Also, due to time constraints, I'm going to talk about geometric distributions in another video. So that's going to be in a completely different video. Okay, so first let's look at this. Probability that x is equal to x is equal to, so mainly there's not much focusing on this part, but what you would do for this part, this is your sample size, right? And this is the value of x. Binomial distributions in this case, you would mainly put this into your calculator, right? So using the math probability button on your calculator, you'd put this, if it depends if you have the newer or the older one. The newer, I'm pretty sure you could just insert the values. The older one, you'd have to first put this n value first and then this x value. But I wouldn't even suggest, unless unless it's like a multiple choice where you're pretty much forced to do this. You could still find a way to use this, which I'll get to later. I wouldn't really stick with this because it's easy. It's pretty vulnerable to make mistakes, and so let me get back to this. So you multiply that by the probability raised to the x power multiplied by the 1 minus probability to the n minus x. So let me admit it. This one's pretty difficult. It takes time. I don't really know people that use this, because it's just tedious. But the College Board gives it to you just in case. What I would recommend 100% is to, oh, it's a bad star. What I would recommend 100% is to use these. Binomial CDF and binomial PDF can absolutely save you. 100%. Like, it's so much easier. Okay, so what is binomial PDF and binomial CDF? So when you go into your calculator, you could click second vars, and you'll be given to a list, and you scroll down, you see options A and options B. Binomial PDF and binomial CDF. So binomial PDF is basically you're given a trials, like as in here, like look, you're given 50 trials, 50 times 50 trials. You're given the sample size 50 trials, given the probability, and a question. Binomial distribution questions largely ask like these expected means and distributions and standard deviations are pretty rare, but the College Board mainly asks the probability of getting success at a certain value. So what does that mean? So let's say there's a sample size of 50. So when you put that into your calculator, you put trials. In the trials section, you would put 50. Let me do PDF first because that's a little easier. 50. and then your p-value. It's going to ask for your p-value next, which is 0.8. And then let's say College Board says, what is the probability that out of the 50 trials that is going to be achieved, the first success, that she's going to score this goal in the 10th trial? You just put that into your calculator. If it says exactly the 10th trial, you put that into your calculator and you get approximately 1.2 times 10 to the negative 19. Okay, so explain that. You might be saying, explain this again. So that's your trials. That's the 50. That's the probability that they give you, probability of success. And that's the trials. This is what really they're giving you, and this is the probability that they're talking about. So remember, trials, probability, and let's say College Board says, what's the probability she scores it exactly on the 10th goal? That's how you do it. Now, PDF and CDF have one clear difference. PDF is pretty much that exact value, exactly on the 10th, while CDF is cumulative. It could be 10th value, 9th value, 8th value, 7th value, so on and so forth. So let's say they score on, she says, College Board asks what's the probability, she scores it on, let's say, 10 or less, right? That would just be 50 times 0.8. The same exact thing, actually. 50 times 50.8 and 10. Those same values. Except this time it's going to be CDF. Here you get a value of 1.3 times 10 to the negative 19. So in this case, it's not that the difference. There are the differences they're pretty close values, but generally it's more distinct. The difference is more distinct, but the key difference is that this is a cumulative. This is more than one. This could be 10, 9, 8, 7, 6. Well, this has to be 10. Like no more, no less. Let's say College Board asks you, what's the probability that she scores what's the probability that she scores at least 4 goals? Like you might be saying, well, 4 goals, but in this case, what you would want to do, whenever they say at least, I cannot stress this enough. Kids would just do binomial CDF, and instead of like here they would put 4, but that is wrong, 100% wrong. What you want to do is, what's the probability she scores at least 4 goals? You would do binomial CDF, right? Binomial CDF. Same exact thing. Binomial CDF. Say 4, right? 4 goals. But what you want to do here, oh my goodness, I cannot stress this enough, is that you have to do 1 minus. Now, this would be, because here you're trying to see you're scoring at least this many goals. And so, while here you're just trying to find cumulative. So whenever they say at least, you have to remember this 1 minus part. Otherwise, you're going to just get this cumulative value of 4, 3, 2, or 1. You have to find at least getting 4. So that would be 4, 5, 6, 7, 8, 9. Oh, sorry. Made a mistake. I did 4, but sorry, I can't stress enough about the mistake I just made, learning mistake. If they ask you what's the probability they made at least 4 goals, you have to put 3 here. Now you might be saying, what? 3? Why would you put 3? Because I will talk about it. Binomial CDF. If you put 3, that counts 3, 2, 1. And I don't know if you would count 0, but 3, 2, 1 mainly you can't. But they're asking that you get at least 4 or more. At least 4. That'd be 4, 5, 6, 7, 8, 9. So you can't count 4 here because you're trying to see the probability that it's 3 or less. So that's why you multiply 1 minus it. Because that 3 or less gets that value. When you subtract 1 minus, when you do 1 minus that value, you get the probability that it's 4 or more. So let's just do this in our calculator. So I want you to take out your calculator, put 1 minus, go to second vars, binomial CDF, go plug in those values, and then do 1 minus that. And so your calculator might automatically actually round for you, but I don't know. It was because it was like a probability super small, super small. It was like this small, so your calculator might round it to 1. Calculator might round it to 1, but it's it's like a little less than 1, but your calculator is still going to round it to 1. Just so I would just say less than 1. No, less than 1. But it's like a negligible difference. So I'm going to also be going over geometric on my next video, so make sure to watch that as well. Please leave any questions in the comments, and I hope to see you next video. Thank you.